Hello. In this session, we'll explore iterators and iterables, the core of Python's looping and data traversal model. We'll cover different traversal techniques, iteration transformations, and alternative product protocols, and some advanced uses of ITR function. The iterable is an object capable of returning its elements one by one like lists, tuples, and strings. An iterator is the object that actually produces those elements, typically using the dunder next method. This distinction is fundamental. Iterables provide data sources and iterators consume them lazily. Understanding this allows us to build clean, efficient, and iteration patterns. Tree traverses. Tree traversal is the process of systematically visiting all nodes in a tree structure. There are many strategies. The most common are breadth first and depth first traverses. By using iterators, we can implement these traverses in a lazy, memory efficient way, avoiding unnecessary data structures or building entire lists upfront. Breadth first and level order iterator. Breadth first traversal visits nodes level by level. First the root, then all the children are at the next level, and so on. A queue is typically used to keep track of these nodes to visit. In Python, we can easily turn this into an iterator using a generator function. Each time through the loop, we pop from the queue and yield the next node, extending the queue with its children. This gives us a clean level order traversal without recursion. Depth first. Depth first traversal explores one branch as far as possible before backtracking. In binary trees, in order traversal means visiting the left subtree, then the root, then the right subtree. Python generators make this very elegant. We can simply use yield from recursively. Each call yields nodes in the correct in order sequence without building intermediate list. Filtering the iterators. Filtering iterators only yield elements that meet the specific conditions. The built-in filter function creates a filtering iterator that applies a predicate to each item. Alternatively, you can implement filtering in line with generator expression. For example, filter lambda x remainder of 2 0 range 10, else only the even numbers from 0 to 9. Transforming iterators. Transforming iterators modify elements as they are produced. The map function is a classic example. It applies a transformation lazily to each item. You can also use generator expressions for more complex transformations. This approach allows you to build pipelines of transformations and filters without generating intermediate lists, which is both elegant and efficient. Iterables. An iterable is an object that defines an iter method that returns an iterator. Python's built-in sequences, lists, strings, set stationaries are all iterables. This is why for loops and comprehensions work seamlessly with them. You can make your own classes iterable simply by implementing iter to return an iterator. The alternative iterable protocol. If a class doesn't define ITR, Python falls back to the alternative iteration protocol. It repeatedly calls getItem starting at index 0 and stops when an index error is raised. This mechanism exists for backward compatibility with older sequence style classes. It means that even if you only implement getItem in your object can still be looped. The extended ITR. The built-in ITR function is a two-argument form, ITR callable and sentinel. It repeatedly calls the given callable until it returns a sentinel value, yielding each result along the way. This is useful for reading from streams or any source where a special value marks the end. Classic example is reading lines from a file until an empty string is written. Let's go through the summary. Iterators and iterables form the backbone of Python's data traversal model. Filtering and transforming iterators enable flexible, lazy data processing pipelines. Thank you for watching. Let's meet in the next video.